Well, hello there. It's Mrs. Slater. How y'all doing? So this is gonna look a little bit different, but I'm gonna try to do my normal teaching thing. I'm gonna kind of break this up into more manageable chunks. And so let's go ahead and get started. Sorry, that thing is right in the middle of that. Actually, I'll just try to move this down for you so it's out of the way. But what I'm going to be doing is teaching you a little bit more about chemical reactions. So we've talked about them. I'm going to review a little bit first, and then I'm going to teach you some different types of chemical reactions, which are all really cool in their own way. So let's get going. Okay, this is something that you know. Chemical reaction is just when we take atoms and rearrange what the atoms are hanging out with. Remember that according to the law of conservation of mass, we cannot create or destroy matter. So the amount of stuff that we start with is going to be equal to the amount of stuff that we end with. That's not what I wanted to have happen. Sorry. This is new for me. But okay, I'm going to try to make myself a little bit bigger here. Maybe. There we go. There we go. Okay. I brought home some toys with me because I figured I'd be teaching from a distance. So y'all recognize these ball and stick models right here. And you're going to notice that I am holding 2 molecules of water. And just to show you what we might see happening in a chemical reaction is that these bad boys are going to have their bonds break off one another. So I'm going to have those ones break apart. And then I'm going to have these other ones also break apart. And now I'm just left with a handful of atoms that aren't attached, and I know you can't really see them very well, but I'm just going to take these atoms and I'm going to attach them to each other. This is what happens when water breaks down, if it breaks down through a chemical reaction. So what ends up happening is our hydrogens actually like to hang out with each other. So you'll notice that here's a 1 hydrogen molecule. I've got couple of oxygens. Whoa, I've got 2 bonds. That's really weird. How are these going to go together? These ones. That's going to connect with that right there to make our little oxygen molecule. This is the molecule that helps keep us alive. We breathe it in, and these molecules get delivered to each and every one of our cells so that they don't die. And then the last one that we've got is another hydrogen molecule. These are being finicky. Oop, okay, that's not going to go all the way. But you're going to notice I've got 2 little hydrogen gas molecules here and an oxygen gas molecule over here. And these were produced by my 2 water molecules. So I'm going to actually refer to this reaction a little bit later on. But for now, that's one example of what atoms do in a chemical reaction. They just rearrange. All right. This slide is getting ahead of me, but whoa, geez. Okay, now I'm little again. This is a little bit more review for you. We know that we always start with the things that react, and our fancy word for that is a reactant. So in that last example, my water molecules were my reactants, and the things that got produced were these little guys right here. So because these were the things that were made, these are the substances that we call our products because they were produced as a result of that reaction. All right, so I want you to hang tight and look at this crazy reaction here. You don't have to know what all of these big numbers in front mean yet. I'll eventually be getting there, but all I want for you to do right now is identify what side of this arrow we're going to find the product on and which side we're going to find the reactants on. So go ahead and take a second to do that. And I've got this fancy little thing right here. Let's see if I can actually make it work. These ones right here are going to be our reactants. And then these ones over here, because they were a result of the reaction, are the products. Not cool. I think it's cool. All right. Let me clear all my drawings. I'm gonna go back to using my mouse. All right. Something else for us to remember is how we know a reaction has taken place. We talked about this not too long before we have taken our kind of pause being in the regular school building. But some of the different ways we can tell that a reaction has taken place are usually things we wouldn't normally expect. So if we mix two room temperature things together and get something ridiculously hot or super cold, that's a good indication that a chemical reaction has taken place. If there's a weird change in color that we wouldn't have predicted, or a smell change, y'all remember the smells lab that I know you just loved. And you're missing that butyric acid now. I'm so sorry. But anyway, change in odor, change in pH, which we didn't talk about too much, or if there's an unexpected release of gas, or if you take two liquids and pour them together and all of a sudden you get this solid forming. Those are all kind of weird, unexpected changes that are usually indicators of a chemical reaction. Last one, it's usually really tough to turn what you make back into the stuff that you started with. So if you think of baking cookies, for example, you take all of your ingredients, your flour and sugar and eggs and chocolate chips, of course, and all of the other ingredients, and stick them in the oven. After you've baked them, you can't undo the baking. You can't turn it back into what you've done. And so baking cookies is also another lovely example of a chemical change. And that's indicated, usually there's a little bit of a change in color. So it goes from really light color of the cookie dough and usually becomes a little bit darker. Also, there's that lovely odor that fills whatever space it's baking in. And then again, we can't turn them back into what they started as. You remember these from quite a while ago. A plus just shows what we have on each side of the reaction. An arrow lets us know that a reaction is taking place. And then the S, L, G, and AQ, we learned about those at the beginning of the year, where S just means you've got a solid, L is liquid, G is gas, and we know that aqueous is a fancy way of saying that we've just dissolved that substance into some water. There's some reactions that we want to have take place, like, for example, cellular respiration. I was talking about how we breathe in oxygen and we eat food ultimately so we can have energy, and our bodies actually use that energy in the form of stuff like glucose and the oxygen, and it gives our cells the energy that they need to stay alive, which is kind of an important thing. So I'm thankful for that process up here. You might, I don't know if you are or not, but it's keeping you alive, and I'm grateful for that. It produces carbon dioxide, which we breathe out, and also there's a little bit of water vapor that comes out. So if you go up against like some glasses, you're going to see, oh, nope, you're not going to see it. There we go. That condensation is from the water that is produced by that process. There's others that aren't necessarily very desirable, right, Mr. Slater?
Yeah. Combustion's a really bad thing, especially when it happens spontaneously.
Well, it's cool though. Combustion's a pretty cool reaction. It might not be good if you aren't expecting it.
Like actual people, right? I think.
Yeah, that would
combusted before.
Yeah, we're not getting into that conversation right now.
Oh,
but
sorry.
Hi, I just had the, oh geez, now I'm changing
It's
slides.
Okay.
So for this one, the example that I put is rusting. If you've got a car that looks kind of cool, or really any metal looks
Mhm.
nice and shiny, and it gets exposed to oxygen, it's
Mhm.
going to develop that lovely layer of rust that's actually not so lovely.
Yeah.
And you can't wipe it off because it's not just something that fell on the surface like dust. It is actually the iron that it started out as bonded with oxygen, and now that orangish stuff is stuck there because it is now the iron with the oxygen that's making that new color.
Yeah. Cast iron does that. Cast iron, if you don't take good care of your cast iron pans, they will rust.
It's true.
Hmm.
He knows from experience.
Yeah. So, all right. Good to see you guys. Hope you're doing well.
All right, and I'm gonna go ahead and stop this. And Mr. Slater, if you want to help me stop this, where is it? Stop video. All right, I will see you later, and I will have another video to record up shortly.
True Story
All right.
Friday, too. We got True Story Friday this week.
Yeah, it's Tuesday,
Hey.
but on Friday we'll be
Yes.
back with True Story Friday.
All right. I guess.
Bye.